So I had a question earlier about how to graph an absolute value function with a reflection over the x-axis. And I think the confusion stems from the wording of saying reflection over the x-axis. These would be better described as a reflection, simply as a vertical reflection or as a reflection over a horizontal line passing through the vertex. That would be a line parallel to the x-axis. But however you look at it, when you're actually plotting the graph, you really don't have to worry about specifically plotting the reflection per se. If you simply use the a variable out in front as the slope after locating the vertex, the reflection will take care of itself. So let's take a look at this example. We have a -1 out here in the front. We'll call this, we'll say for this one, we'll say a equals -1, right? And we'll go ahead and also identify that h, also in this case, equals -1. K, since there is no number at the end, equals 0. So we can locate our vertex easily at -1. Let me actually change colors here. This is too much red. -1, 0. That's where our vertex is. So if we go ahead and plot that point, -1, 0. I'll actually do this in a color. We'll do it in blue. There's our vertex at -1, 0. Now, to plot the absolute value function, I'm going to take a. So in this case, again, a equals -1. So on the right-hand side, my slope will equal -1. So when I go to plot a couple of extra points here, I'm going to go down 1 over 1 rather than up 1 over 1 because my slope is negative. And then I'll go ahead, if you're using a straight edge, 1 point is plenty. I'll go ahead and plot a couple more points here. Down 1 over 1, down 1 over 1. And I'm going to draw a line passing through all those points starting at the vertex. So there's the right-hand side. And actually, why don't I go ahead and I'll sketch in my axis of symmetry just to give you the thought process that this graph is symmetric about some vertical line. It's a vertical line that passes through the vertex. Now, the slope on the other side, the slope on the left-hand side, is going to be the opposite of a. So my slope over on this side will be +1. So since I am reflected, I'm going to be going down 1, left 1, down 1, left 1. As many points as you need to get your line. But here you see we have a positive slope. So that's a reflection. In this case, it actually is over the x-axis. But let's just say if we had also had, let's rewrite this, y equals negative of the absolute value of x plus 1. And we'll give this one a vertical shift. We'll say, we'll go up 3, which gives us a vertex of -1, 3. So you see this a little bit better. Our vertex, and we'll do this one in red to contrast. So -1, 1, 2, 3. Now our vertex is up here, but you see still that the slope takes care of the reflection for me. And it's not actually reflected over the x-axis, but it's reflected over a line parallel to the x-axis, a horizontal line that passes through the vertex.